In this video, we're going to find the remainder when f of x is divided by x minus c and or determine if x minus c is a factor of f of x. So I'm going to use the zero factor theorem that says if x minus c is a factor of f of x, then f of c equals 0. If I set this factor equal to 0 and solve, I get x equals c. Stick c in, it's going to be a 0. If it equals 0, now what they're talking about with the remainder theorem here is that if I use long division or synthetic division, if you know synthetic division already in your class, and divide through by this divisor, get a remainder of 0, then it's a 0, it's a factor when you get a 0 remainder, and then you can confirm it that way. So there's a couple of different ways here. I'm going to use both. I'm going to start off with long division on this one. X minus 2 into 4x to the third minus 9x squared plus 8x minus 3. 4x cubed divided by x is 4x squared. It's 4x cubed minus 8x squared. I'm going to change my signs and add. It's negative x squared plus 8x. It's going to give me a negative x. When I divide here, that's negative x squared plus 2x. When I multiply negative x times x minus 2, I'm going to change my signs and add 6x minus 3. That's going to be plus 6 and give me 6x minus 12. Change my signs and add, and I get a remainder of 9. Now let's see if there's another way that I could have gotten that 9. If I would have taken this linear factor of x minus 2 and set it equal to 0, I would have gotten x equals 2. And let's see what f of 2 is. 4 times 2 to the third minus 9 times 2 to the second plus 8 times 2 minus 3. 4 times 8 minus 9 times 4 plus 8 times 2 minus 3. 32 minus 36 plus 16 minus 3. That's a negative 4 plus 16 minus 3 is 12 minus 3 is 9. And I get the same 9 whether I get it as the function value this way or the remainder from long division that way. It's the same thing. So sometimes long division is going to be okay. There's also another technique that's called synthetic division. I'll show it to you now. We're going to talk about it a little bit later in the course here, but I'll show it to you now. If I take that linear divisor, meaning that's the equation of a line, such as x plus 2, set it equal to 0 and get x equals negative 2. I'm going to put that negative 2 on the outside here, and I'm going to put all these coefficients here, 4x to the 6th, but then I have a 0x to the 5th, a 0x to the 4th, a 41x to the 3rd, a 0x to the 2nd, a 0x to the 1st, and a 72x to the 0, the constant there. So I'm going to bring down, multiply and add, 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 and multiply and add, and that's my remainder right there. So yes, that was a 0, or that was a factor because it has a remainder of 0. And this line down here represents that this is x plus 2 times 4x to the 5th minus 8x to the 4th plus 16x to the 3rd plus 9x to the 2nd minus 18x plus 36. That's my other factor if I would have done long division. Now, let's go ahead here. This one has a lot of missing terms here. I'm going to use synthetic division again for this one, where the divisor is x plus 4. Going to set that equal to 0 and solve. I'm going to put a negative 4 out here, and I have 4, then 0x to the 5th, negative 64x to the 4th, 1x to the 3rd, 0x squared, 0x, and a negative 1. So bring the 4 down. 4 times negative 4 is negative 16. And add, and then that's a positive 64 is going to be 0. And that's 0 plus 1 is 1. And then that's negative 4 plus 0 is negative 4. That's 16 plus 0 is 16. And negative 64 plus a negative 1 is negative 65 for my remainder. So no, it is not a factor. You could have also evaluated this one at 4 times negative 4 to the 6th minus 64 times negative 4 to the 4th plus negative 4 to the 3rd minus 1. But I didn't want to get all those big numbers with those exponents there. So this synthetic division method helped me avoid all of that with simple multiplication and addition. It gets me to the same place. It's a very powerful tool that we're going to use not only to test for zeros and to help us with factoring in upcoming technique or objectives here, but also you see that it can help us evaluate a function that if we put the number out here and put the function here, this number over here is also going to be the function value. So why is that? As I wrote it in factored form here, if I stick this negative 2 into this, this is what f of x is equal to right here in factored form. If I stick negative 2 in there, 0 times anything over here is 0. If I end up with a remainder there, it looks something more like this. X plus 4 times 4x to the 5th minus 16x to the 4th plus 0x to the 3rd plus x squared minus 4x plus 16. And then minus 65 is out there as a remainder. So if this is f of x and I stick negative 4 into the function, this becomes 0 times all of that. Minus 65 is 0. Minus 65 is a negative 65. So this remainder is also going to be your function value later. So I'll be using this technique here to even help me evaluate functions in the future. All right, that's it for this video, and we are going to come back next time and talk more about 3.3. See you for the next video.